my class 10 students, welcome to today's session. I'm Aditi, your physics teacher, and I've brought you today top 10 electricity numericals. Yes, we are going to revise all the basic, the hard, the moderate numericals of the chapter electricity. We know it is highly numerical based chapter. And there are multiple kinds of numericals in this whole chapter, right? So we will look at all of those kind of numericals, right? So let's start today's session. Okay, so the first numerical that is there for today for us is, if length of wire is increased by 20% by stretching, change its resistance and resistivity, which changes its resistance and resistivity. Calculate the percentage change in its resistance and resistivity. We have a wire, okay, and this was the length. Let's say the length was L of this wire. So they are saying that we increased the length of this wire by how much? By 20%, right? So how will we solve this question? Let's look into one, right? So in the first case, we have two cases, right? For the first case, L1 was simply L, correct? Now in the second case, L2 will be L1, but it is increased by 20%. That means plus 20% of L1, 20% of the original length. Understood? Then L2 will become what? L1 plus 20 by 100 L1, which will become L1 plus 0.2 L1, right? So L2 will be 1.2 L1 or 1.2 L, correct? Now the keyword here is, it is stretching, and we know if the length, if the wire is stretched, that means length increased, but area decreased by the same factor. That means area decreased by 20% as well. So A2 will become A divided by 1.2. Understood? So this is our final statement. Now we have to find resistance first. So resistance R1 will be what? Rho L1 divided by A1. This was before stretching. After stretching, R2 will be what? Rho L2 by A2, correct? Now one important thing, they have asked us how much the resistivity will change. Ma'am, we know that resistivity does not changes. You know that, right? Resistivity, it is the same material, it is the same wire, so resistivity for both will remain same. Rho 2 will be equal to rho 1 will be equal to rho, correct? Resistivity will never change as long as the material of the wire is same, correct? So next is, this is rho L2. How much L2 we got? That is 1.2L, 1.2L, correct? And A2 is A by 1.2. A2 is A divided by 1.2, correct? So you can just solve this, rho L by A, and this will be 1.2 whole square. So what is the whole square of 1.2, or let's say 12? That is 144. So rho L by A, and this will be 1.44. Understood? So R2 will increase by the factor of 1.44 than R1. Correct? This was R1. L1 is L, right? R1 was rho L by A, correct? Done with this question? Understood? Okay, let's move on to the second one. Just as electricity is supplied at 220 volt in India, it is supplied 110 volt in USA. So they're saying, just as we know in our households, we get voltage as 220 volt. But they are saying that in USA government give them a voltage, a potential difference of 110 volt, correct? Now if resistance of 60 watt bulb, we have a bulb whose power is, right, 60 watt is power, whose power is 60 watt bulb for use in India is R. That bulb whose power is 60 watt will give resistance as R in India, right? R in India, let's say I, this is I, this is USA, and they are asking then that of a same 60-watt bulb for use in USA will be. So the resistance of the bulb, that is R in India, how much resistance of that bulb will be in USA for the same power of the bulb but different voltages, right? So RU we have to find. Understood? Now seek here carefully. Power is same, right? Power is 60 watt in both cases. So power of that bulb in India is equal to the power of bulb in USA. Correct? Understood? Now power formula is V square by R for India equals to V square by R for USA. Correct? Understood? It's making sense, right? Now what we have to do? We have V square by R for India, V square by R for USA, right? We'll just fill the values. For India it is 220 divided by R is same, correct? This is squared. Now yeah, so let us write here India, okay? So 110 whole square divided by R of USA. Understood? Clear? ठीक है? अब we'll just replace this, rearrange this whole statement. Does this makes sense to you? R of India divided by R of USA. Just yes, here the 2 won't be here. It will be here because R is not the square, right? It is V square by R. Now it is correct, right? Same for here. So yeah, this is good. This makes sense, right? So if I just solve this, this will be 2 square 4 equals to R of India divided by R of USA. So my friends, R of USA will be R of India divided by 4. Understood? Clear? Okay, very easy, very basic. Power is same, so we equated the powers of in India and in USA. Done? Chalo. Next question. What is the equivalent resistance across A and B? This is A, this is B. If R equals to 3 ohm. R is 3 ohm is given and we have to find equivalent resistance. Done? Correct? Now, what we have to do? This is a combination of resistors. So we'll simply add and combine all these resistors as it is given, right? So see, first these two are in series. Let us name them, okay? Let us name these. Let's say this is R1, this is R2, this is R3, R4, R5. Correct? So now tell me, isn't R1 and R2 in series, right? So we'll write R1 and R2 are in series. So we will simply add them. So R12 will become R1 plus R2. That will be 2R. Right? Till here any doubt? Now this this diagram will become something like this. Right? R12 and this cancels out. Correct? This cancels out. Now this diagram, now these R4 and R12 are in parallel. We can clearly see that R2 and R4, R12 and R4 are in parallel, right? So we can use the formula of resistances in parallel. That will be 1 by R4 plus 1 by R12. Correct? That will be 1 by R plus 1 by 2R. Correct? That will be, now just take the LCM, 2R, 2 plus 1, that will be 3 by 2R, and R equivalent of R412, 412 will become 2 by 3R. Understood? Till here, any doubt? Correct? Understood? Now, let us make this diagram again. Okay? So this is A, this is one resistance, this is B, this is another resistance, and this is the total resistance of these two resistances. Correct? Understood? So we have this as 2 by 3R and this is R and R. Now all these three are in series. All these three are in series, right? So we'll just add them. R plus 2 by 3R. Simple. Very, very, very simple. 3 plus 3R. Yes, 3R plus 2R. That will be equal to 8 by 3R. So total resistance of this circuit becomes 3 by 2R. Understood? Everyone, if anyone has any doubt, you can write down in the comment section. Okay? And we'll solve them. You can come in live. You can get your doubts cleared. Okay? Chalo. Next question. The question says you have 4 resistances. Wires of same material, and the 4 resistance wires have same material. Select the wire which will offer the least resistance to the flow of current. They will offer least resistance to the flow of current. Now, the one thing you can do is you can solve all these questions. Okay? But we'll work smartly. We know resistance is rho L divided by A, right? Now R will be more for, it is directly proportional to L and inversely proportional to area. That means inversely proportional to diameter. Correct? This question I am giving you as homework. Let me know in the comment section. I am giving you a hint, right? See, even though we know this formula, and according to that, what is the highest length? The highest length is, okay, we want minimum resistance. And for minimum resistance, we want minimum length, right? Minimum L and maximum diameter. That is true. So out of these 4, what is the minimum length? My minimum length is L by 4. But maximum diameter, so it is 2 by 2D. So what will be the answer? So you do have to solve this, right? You have to solve this, write down the answer in the comment section. Just use the value of L, that is given as 2L, and D as 2D. So R will be what? R will be simply D. Now just use it. I'll find the resistance for the first case, that is rho L by A. Now that will be rho into 2L divided by pi D square. Understood? Because for wire, area of cross section is pi R square. Correct? So R1 will be rho 2 rho L by pi D square. Similarly, you have to find for all these 3 options, and then you have to tell which one of these will have minimum resistance. Correct? Chalo. Next question. We have the minimum number of identical bulbs of rating 4 volt and 6 watt that can work safely with the desired brightness when connected in series with a 240 volt mains supply. So see, we have 240 volt mains supply, correct? This is what the question is saying, and we have some few bulbs. We have, I don't know how many bulbs, I don't know the number of these bulbs, but there are some bulbs and these are connected in series. Correct? These are connected in series. You have to write it down. These are connected in series. Now, they are asking how many bulbs should I connect, and the voltage of each bulb is 4 volt and power of each bulb is 6 watt. Right? How many bulbs should I be connected in series so that the total voltage is 240 volt, right? Now, listen carefully. These bulbs are connected in series, right? Correct. Now let's say these are 4 bulbs, so voltage is 240. Now each bulb has same power, and since each bulb has same power, the voltage will be distributed equally. So what will be the voltage? Total voltage divided by number of bulbs, that will be 60. We got 60 here, right? But now see what we have to do. Why can't I erase this? Okay, what we have to do now, listen very carefully. This total voltage will be divided into n number of bulbs, right? And for each bulb the voltage is 4 volt. So we'll simply use that this 240, the total voltage will be equal to the number of bulbs and the voltage of each bulb, right? So this total voltage is 240, number of bulbs we have to find, and for each bulb the voltage is 4. So from here n will be 240 divided by 4 and this will be 60. That means we can connect 60 bulbs in series. We can connect 60 bulbs in series so that each bulb gets a voltage of 4 volt when the main supply is 240 volt. Understood? Chalo. Next question, find the current flowing through the given circuit. Ma'am, this is very easy. This is just the combination of resistors. Don't panic. Read the diagram very carefully. Okay? These is the combination we will use first, right? 1, 2, 3 and 4. So 2 and 4 are in parallel, we can clearly see. So I can just do 1 by R2 plus 1 by R4, correct? That will be 1 by 2 plus 1 by 2. Khatam, and this is 1. So R24 becomes 1 ohm. And now this whole circuit becomes what? This is something like this, correct? This becomes something like this. This is 1 ohm, this is 1 ohm and this is 6 ohm, correct? If this circuit becomes like this and this is 4 volt, we just have to find the current now. Isn't it easy? All these three are in series. So my total resistance will be what? 1 plus 1 plus 6, right? That is 8 ohm. And now Om Baba ki jai. Om Baba told us that Om Baba ka law hai na ye. Om Baba told us ki V equals to IR. So V कितना है 4. I we have to find and resistance is 8 ohm. So I will be 4 by 8, that means 0.5. So I is 0.5 ampere. Do not forget the SI units. Okay? So, next question. An electric motor rated 1100 watt. This question is very important. That's why I have repeated it in my live, in my videos as well, because this is a very important conceptual question, right? So do not forget to miss this. Do not forget to learn this question, learn the concepts of this question. Okay? Now देखो. So electric motor is rated 1100 watt. So this is 1100 watt connected to a 220 volt mains supply. This is 220 volt mains supply. Then this is what is given. Find the current. Ma'am, what kind of question is this? We know the basic formula of power is what? It is V into I. Right? Now V is given 1100, voltage is given 220 and this is I. So this is I will be what? 1100 divided by 220 and that is 5, my friend. So I is 5 ampere. Correct? Till here everything is basic, everything is simple. Now, electrical energy consumed if the motor is used for 5 hours daily for 6 days. See, now we have to find electrical energy. What is the unit of electrical energy? Ma'am, it's kilowatt hours, right? But here we have power in watt, correct? So we have to first convert the power into kilowatt. That will be 1100 into 10 raised to power minus 3 kilowatt, correct? So power will be 1.1 kilowatt. Okay, this is my power. Now what was the time? The time is used for 5 hours daily for 6 days. That means how many hours? 5 into 6. Basic. So the time is 5 into 6 hours. That means time is 30 hours. Correct? Now we can use the formula of electrical energy, that is power into time. Correct? So power is 1.1 and time is 30. So this will be 33 kilowatt hour. Understood? Electrical energy comes out to be 33 kilowatt hour. Very good. Now there is another point left. they are asking what is the total cost of energy consumed if the rate of 1 unit is 5 rupees. Now 1 unit is actually equal to 1 kilowatt hour. Understood? 1 unit is definitely equal to 1 kilowatt hours. Okay? So we had 33 and ruko. And the rate of 1 unit is 5 rupees, right? And so 1 kilowatt, rate of 1 kilowatt will be also 5 rupees, correct? Now let us solve the question. We have electrical energy as 33 kilowatt hours. We have 33 kilowatt hours. So for 1 kilowatt hour, the cost is rupee 5. And for 33 kilowatt hours, what will it be? Let me know in the comment section what will be the answer to this question. We'll see how many of you got the answer right. Okay? Along with units, it's just rupees. Okay? Okay. Chalo. Next question. Find the minimum resistance that can be made using 4 resistors, each of 20 ohm. So we have 4 resistances. R1 is 20 ohm, R2, R3, R4. All are what? All are 20 ohms. How can we arrange these resistors in parallel, in series, one in parallel, one in series, so that we get minimum resistance? Ma'am, this is just basic simple question. We know because when we need minimum resistance, we connect all the resistances in what? In parallel. Yes, resistances will be connected in parallel, correct? Will be connected in parallel. So all will be connected in parallel. That means 1 by 20 plus 1 by 20 plus 1 by 20. That will be 4 by 20, which will be 1 by 5. So the resistance of this combination will be 5 ohm. Correct? This will be 1 by R of P, right? 1 by RP. And hence RP will be 5 ohm. Understood? Very easy question, but very conceptually rich, because you should know in which case the resistance is minimum so as to know how they should be connected. Right? Chalo. Next question is, an electric kettle rated at 230 volt and 1000 watt, calculate the resistance of its heating element when it is in operation. So electric kettle, we are given potential difference, that is 230 volt, okay, and power is 1000 watt. We just have to calculate their resistance, right? So we know very basic formula, P equals to, I'm saying basics to everything, but these formulas are very important. Okay, we have a kettle, it is rated, its potential difference is given, its power is given. We have to calculate how much resistance it will take. Okay, so we have the formula of power as V into I. It is always also equal to I square R and equals to V square by R. Now in this case we are given with power, we are given with voltage, but we are given with the resistance. We have to find the resistance when voltage and power is given. So which formula will we use? We'll use V square by R. That's how you have to think. Okay, so V square is 230, that means 230 into 230 divided by R. I have to find power is 1000 watt, right? So R is 223 into 23 into 100, whatever you can write, okay, divided by 1000. This 100, 2 zeros get cancelled out. Now the square of 23 is, let us calculate 23 into 23. What will it be? 69 into 64. It will be 529. Correct? Divide by 10. So resistance will be 52.9 ohm. Okay? Understood everyone? Correct? Chalo. Next question. How is electric current related to potential difference? How is electric current related to potential difference across the terminals of a conductor? And this feels like something I might know. right? This is the very basic question, but it has come in CBSE board examination. Okay, so see, they are just asking you the relationship between potential difference and current. So we know they are directly proportional and V equals to IR. See, again very basic Ohm's law, right? There was nothing but Ohm's law, but they have followed this question with another question which requires conceptual knowledge. Okay, what they are asking is, why should an ammeter has low resistance? Ma'am, ammeter, why should ammeter has low resistance? So we'll go through it step by step. Okay, ammeter, see what ammeter is. Ammeter is a device to measure the current, right? It is a device to measure current in the circuit, and we know that ammeter is always connected in series with the resistor. Correct? It is connected with in series with the resistor. That means the same current that is passing through the resistor or through the whole circuit will be passing through the ammeter, right? That is why we need it to be of minimum resistance, because what resistance does is, resistance causes the flow of charges to stop, causes the hindrance to the flow of charges, to the flow of current, right? But ammeter is a device to measure what the current is, what amount of current is going through that circuit. If it has more resistance, it will also cause a hindrance to the flow of current, and if it causes hindrance to the flow of current, it will not be able to measure the exact amount of current that is passing through it, because now the current is not passing through it with the whole amount, because the ammeter is in itself causing resistance to the current. If it is causing resistance to the current, it won't be able to measure the actual amount of current that is passing through it. समझ में आया? Understood? Very easy. Basic. Ammeter is always connected in series. As ammeter is always connected in series, the same amount of current will pass through it as the same amount of current that is passing through the whole circuit. And for it to measure the value of current correctively, efficiently, it should have low resistance, so as it doesn't produce any hindrance to the amount of current that is passing through the circuit. Understood? I've said all the answer in one go. Okay? You can write it directly. Correct? So, next part, two VI graphs A and B, this is A and this is B, are given. These are for series and parallel combination of two resistors. We have to show which graph is for series, which is for parallel. Is A for series or is B for series? A for parallel, B for parallel. Right? We have to show that. Now, how will we show that, ma'am? That will be shown by our intelligent students. Right? This is given. This is A and this is B. See, VI graph, V and I are related with what? With resistance, Ohm's law, right? So, V equals to IR, correct? So, R from here is V by I. Understood? Now, we also studied when we were studying Ohm's law, when we were studying the graph, that V and I, the slope of V and I graph gives resistance, right? So, let us find the slope of this particular graph. What is the slope of this particular graph? That will be y-axis divided by x-axis. Now, y-axis is V and x-axis is I, right? So, slope is what? Also R. Right? The slope is also R. That means more the slope, more will be the resistance. Right? These two are same, correct? So, slope is equal to R. Slope of this graph is equal to R. Correct? That means if slope of a particular graph is more, the resistance of that particular graph is also more. Right? So, which of these has more slope? Slope of A is more or slope of B is more? Slope of A or slope of B? You let me know the answer to this in the comment section. Slope of A is more or slope of B is more, and then which of the resistance will be for series, which will be for parallel. Okay, let me tell you just this one thing. What is it? For minimum resistance, for minimum resistance, slope will be now I told this ulta. For parallel combination, resistance is always minimum, and for series combination, resistance is always maximum. Now you find out which of these has more slope, that graph will have more resistance, and then that graph will be of series. Understood? And then find out which slope is less, which resistance is less, then that slope, then that graph will be of parallel combination. Let me know in the comment section right now. Okay, we are done with 10 questions of the chapter electricity. We saw series parallel combination, we solved their diagrams, we solved the circuits, and then we moved to power, electrical energy, heating effect, everything, right? So make sure you practice all these numericals. These should be engraved in your brain, right? So make sure you practice these numericals and make sure you revise them again and again. If you think you are not able to solve a particular kind of numericals, go back to the concept, watch some videos and see how to actually solve that numerical, what is the right approach to solve that numerical, and then come back to the question. Okay, that's how this is the time where we do that, right? We solve the questions, we revised, we solve the questions. If you are not able to solve the question, revise back, come back, right? Understood? That is it for today's videos. I'll meet you in the next one. Till then, tata, bye bye.